Hi, welcome to week 2. We're going to be covering chapter 3. Now, chapter 3 kind of gets into the meat and potatoes of programming, which is basically all about decision making. Basically, we give the computer a choice, and it's going to basically be A or B or whatever the case may be. Now, what is based on, if statements are based on Boolean logic, B-O-O-L-E-A-N. And that basically means true or false. It's going to ask, is this equal to this, or is this greater than this, is this less than that? It's going to basically ask a Boolean question, and it's going to come back either true or false. If it's true, it's going to go into the if statement. If it's false, it's going to do something else. On page 120, it shows a flow chart. A flow chart is basically a diamond. And so this diamond, let me kind of draw it out for you here. So the diamond is going to be, so with our flow chart, we have an arrow coming in, and then we have our diamond. The diamond basically says, for example, is X greater than Y? If it's true, it's going to come over here and do this calculation. But if it's false, it's going to come here. So if it's true, it does this. If it's false, it goes this route. So as we come into the flow chart, we basically have this decision of whether if X is greater than Y. If it is, we're going to come over to this side, and we're going to do whatever the program basically needs to be done at this point, and then it will come back into the rest of the program. If it's false, it's just going to come straight through and do nothing in this case. So that's basically an if statement and a flow chart and flow charting. Let me try to erase this. So anyway, so in our code, we'll do things like is X greater than Y? Is X less than Y? Oh, come on. Don't try to second guess me. Is X equal Y? Is X greater than or equal to Y? Is X less than or equal to Y? And we always do the greater than or the less than before we do the equal. Is X not equal Y? And that is an exclamation point. So there is a table on page 122. Those are called the relational operators. And we've got, oh, by the way, equal is always two equal signs together. When I use a single equal sign, that is basically what I'm saying. I want A equal to 304. So I want to put the number 304 into the variable A. We use a single. If I want to do a comparison, we always do two equal signs side by side. So if you ever try to use one in a comparison, it is going to try to basically make that variable equal to another variable. So just be aware of that. A comparison is a double equal sign. So that's basically on page 122, table 3.1 and 3.2. So let's kind of look at some code now. So on page 126, we've got the test average. So let's go ahead and open up test average. And there it is. So it says this program gets 3 test scores and displays are average. It congratulates the user if the average is a high score. The high score variable holds the value that is considered a high score. High score is equal to 95. So we're going to ask the user for test input 1, and we're going to convert each one of those inputs into an INT. So it's going to be an integer, no decimal places. And then we're going to calculate the average is equal to test 1 plus test 2 plus test 3 and divide by 3. And then we're going to say print. We're going to use the printf. In this case, we're going to take the average. So we're going to say the average score is, and then we're going to take whatever is in that average variable and display it here. We're going to say if the average is greater than the high score, we're going to say congratulations, that is a great average. Now before I continue, I want you to pay close attention to these 2 lines. Notice that they are indented in. Now, Python is all about indentation. And what do I mean by that? Well, let's just say this. Since these 2 are indented in, they go with this if statement. So if this if statement is true, it's going to print that line and then print that line. Now, if I did this and put that line back to that, it's no longer attached to that if statement. So if this if statement is false, it's not going to print congratulations, but it is going to print that is a great score. So I'm going to show you what I mean by that. So first let's run it. So I'm going to enter test score 1. I want to put 90. I'll put 99, and then I'll put 94. And it says the average score is 94.3. So we just quite didn't make 95. So let's run it again. We'll put 99. We'll put 96. We'll put 95. And it says, the average score is 96.6. Congratulations, it's a great score. Now this time I'm going to take this last print statement. I'm going to basically no longer have it indented underneath the if statement. And watch what happens. So I'm going to type in 90, 92, and 93. And it says the average is 91.6666. That is a great score. We didn't want that to print unless that statement was true. But since it's not indented in, so this is something you have to really get used to with Python, is that if you want a particular item to go with something, you have to indent. Indentation is the key here. Now be careful. Whoop. Be careful not to indent too much. Why is it not working? So be careful not to indent too much, because it will take it away from that and try to put it underneath another item as well. So you have to indent in once, so just one tab key in. Okay. Now, in this particular case, if it's true, it's going to do that. If it's false, it does nothing. So we do have what's called the else statement. So let's go ahead and open up auto repair payroll. And again, if you're following along, you can go ahead and pause the video to open it up and then basically come back, or you can try to, basically kind of follow along with me. Okay, so here I've got base hours equals 40. Our OT multiplier is 1.5. And then we're going to go ahead and get the hours worked, and we're going to this time we're going to convert it into a float. So it is going to have decimal places. We're going to have the user enter the number of hours worked. Pay rate is also going to be a float. We're going to also have them input the hourly rate. And notice now we've got if hours are greater than base hours. we're going to say overtime hours is equal to hours minus base hours. Overtime pay is equal to overtime hours times pay rate times OT multiplier. So if you worked over 40 hours, if you worked 43, we're going to take hours and subtract base hours. Now what are base hours? 40 hours. So we subtract the 40, we have 3 overtime hours. We take overtime pay is equal to overtime hours times pay rate times that multiplier of 1.5. And then our gross pay is going to be the base hours times pay rate plus the overtime pay. If hours aren't greater than base hours, else says if this statement is false, we're going to do whatever's in the else statement. We're going to do gross pay is equal to hours times pay rate. Now notice the next statement of print is not indented in, so it's not part of that else statement. So it's going to be a print F. It's going to say the gross pay is $, and there's our gross pay with a comma separator and 2 decimal places. So let's run it. Hours worked are going to be 45. Hourly pay rate we'll say is 12.75, and the gross pay is $605.62. So we got five hours of overtime pay, which is the 12.75 times 1.5, multiply times 5. We add that to just our regular gross pay of 12.75 times 40. Okay. So, if-else statement. If says if it's true, do this. If the statement's false, we do whatever's in the else. And again, remember the indentation is the key here. We have to make sure we indent to know what goes with the if and what goes with the else. Now, what can we do for strings? Well, let's go ahead and open up password. And password basically says, okay, I've got my password. It's going to be equal to input, enter the password. So just a regular string, the person typing in password. Now the password is supposed to be PROSPERO. So if what they typed in is equal to that, we're going to print password accepted. If that's not true, we're going to print sorry, that is the wrong password. So if we click run, and I'm just type gobbledygook, it comes and says sorry, that's the wrong password. But if I run it again, and I type PROSPERO, it says password accepted. Okay. Okay, now let's do some other string comparisons. So let's go ahead and open up well, let's just do this. What if I had, I'm going to have the user enter, I'm going to say name 1, and I'm going to say enter name. Enter name 1. I'm going to go ahead and duplicate that line, and I'm going to say name 2. Enter name 2. And I'm going to say if name 1 is greater than name 2, I'm going to print name 1 is greater than name 2. Else, I'm going to print name 2 is greater than name 1. Okay? So, if we go ahead and run this, and the example they use in the books, I'm going to type in Mary and Mark. It comes back and it says name 1 is greater than name 2. Now, how did it do the comparison? Well, the very first thing it does is it looks at the first 2 characters, says is one greater than the other. Now, what's it looking at? Well, each letter has a numeric value. It's called an ASCII character. And an ASCII is a two-digit code. It's called a hexadecimal code. And it's going to check to see is one greater than the other because they are numeric. If they're the same, then it goes to the next one. Is A and A? Well, not one's greater than the other. R and R, they're still the same. Now it looks at the Y. Well, the Y has an actual greater number than the letter K. The Y has a 120 ASCII character, and the K has 107. So 127 is actually greater than 107. So that's why it says name 1 is greater than name 2. So just realize that when we're comparing strings, it's going to, now if one was 6 characters and the other one was only 4, well, obviously the 6 character will be larger than the other one because it's going to try to check that the comparison of that. Well, actually, probably it's going to be a null value, and null is just a 0, 0 numeric value, and so any number is going to be greater than 0, 0. Okay, and that's kind of what they're showing there on page 133. Now, here's what I want you to do is I want you to pause this video, and I want you to go to page 161, and I want you to do programming exercise number 1. So go ahead and do that, play around with that, and when you get done, go ahead and resume the video, and we'll continue on from there. Okay, starting at page 135, we get into this thing called nested if statements. So let's do this. Let's open up lone qualifier. And so here, lone qualifier, we have 2 constants. Remember, whenever we make something all uppercase, we're going to call that a constant. It is changeable in most of the languages. Constants are not changeable, but we can modify it. But just realize when we see all uppercase, we just leave it alone. So we got min salary at 30,000 and min years at 2. I'm going to say salary. We're going to get from the user and convert it to a float. Enter your annual salary. Years on the job is going to be input from the user and convert it into an int. And we're going to say if salary is greater than or equal to min salary, we're going to, and if years on the job are greater than min years, we're going to print you qualify for the loan. Now, if this first if statement is false, it's going to go straight down to the else and print you must have learned at least min salary per year to qualify. And we're using an F print so that we can use the comma separator and run to 2 decimal places. Okay. Now, if this first if statement is true and this second if statement is false, it's going to do the else for the second if statement. Again, remember, indentation is the key here. We're going to print you must have been employed for at least min years to qualify for the loan. Okay, so let's run this, and we're going to enter 50,000 for the first. We're going to enter they've been there for 1 year, and it comes back and says you must have been employed for at least 2 years to qualify. So let's rerun it. This time we're going to type in 25. And 3 years, and it comes back and says, you must earn at least $30,000 per year to qualify. So, nice thing about this is whatever feature. So this is called the nested if. And what's nice about this, in this particular case, if we don't make enough money, it tells us that. If we don't have enough years, it tells us that. 2 separate statements to let us know. So that's kind of nice. But notice we've got an if inside of an if, called a nested if. In order to get to this second if, the first one has to be true. And if the first one's true and the second one's false, it will do the nested else statement inside of there. I keep wanting to ask you any questions, but you can't. Now, let's take a look at a lot of nested ifs, and we're going to look at the greater program. And here we've got three scores. We got A score, B score, C score, and D score. A score is 90, B score is 80, C score is 70, D score is 60. So we're going to say so we're going to get a score from the user. We're going to convert it to an int. And we're going to say if score is greater than or equal to A score, we're going to say you got an A. Else, and then another if. Now look at this. This is kind of a different nested if statement because the if statement is nested inside of the else. So if that statement's false, we come into the else and say if the score is greater than or equal to B, or greater than the B score, which is 80, you got a B. Else, if that's false, we're going to do the else if score is greater than or equal to C, you got a C, so on and so forth. So when we run this, we type in a 75, it comes back and says your grade is a C. And if we run it and type in a 55, it says your grade is an F. Okay? So, now, as you can see, if we had a lot of ifs and elses kind of nested together, this thing would really just kind of tilt out and keep going all the way to the right-hand side because we'd have to keep tabbing in. Well, we do have another way we can do this with what's called the else-if statement. So, what we could do is this. It's just called elif, okay? So let's take a look at it. We've got if score is equal to A, greater than or equal to A score, you get an A. Elif, so it's basically saying, hey, if this one's false and this one is true, then make it the B score. But the nice thing about the else if statement is everything is basically lined up. There's no indentation out, so this thing could kind of go on further. And let's see how it runs. So again, if I run it and I type in a 75, I got a C. If I run it, I got a 55, I got an F. I run it and I got an 82, that's a B. So, else if statement. So if you're going to do this whole big else if statement, instead of having it tab all the way in, having a bunch of nested ifs inside of an else, you probably want to use the else if statement. I guess they would call it the elif statement because it's just E-L-I-F. We don't actually spell out the word else. It's just E-L-I-F, elif. Okay, why don't you pause the video right here and go over to page 161 again. This time I want you to do the areas of rectangles number 2. Now what this is saying is it wants you to get the length and width from two different rectangles and see which one has the greater area. Remember, area is length times width. So you're going to take the length times width of one rectangle and the length times width of another rectangle, and you're going to compare the area of one to the other and say which rectangle has the larger area. So go ahead and take a few minutes and do that. When you get done, go ahead and come back and unpause this video. Okay. Continuing on page 143, we get into this thing called logical operators. And this is where we use one of three words. We use an and, an or, and a not. So let's just kind of, so here's kind of how it works. Is I'm going to have an if statement, and I want to say if true and true. What that says is, so I might have something like this. If A greater than B and C greater than D. Now, here's what this is saying. Here's what this is saying. In order for this entire if statement to be considered true, A has to be greater than B and C has to be greater than D. So if you look on page 144, the truth table for the AND operator, if we have true and so let's say A, well, let's do this. I'm going to say A is equal to 5, B is equal to 4, C is equal to 10, and D is equal to 12. Okay? So, is 5 greater than 4? It is. That is true. Is 10 greater than 12? No, that statement is false. In order for this statement, this if statement to be true, on both sides of the AND statement must be true. So in this particular case, it's not. This if statement is false, and it's going to do whatever's in the else. Okay. So if I change that to a 9, well, let me do this. I'm going to leave that. I'm going to do that. I'm going to change B to a 6. Okay. So is 5 greater than 6? No, it's not. So that's false. Is 10 greater than 9? That is true. So we've got a false true. But again, in order for that statement, entire statement to be true, the AND says both sides of the AND must be true. So I'm going to change that to a 3. So is 5 greater than 3? Yes, that's true. Is 10 greater than 9? Yes, that is true. So the entire if statement is true, and it will basically do whatever's inside the if statement. So, AND statements say both sides of the AND must be true in order for the whole thing to be considered true. Now, the OR statement is a little different. The OR statement says only one of these guys has to be true in order for the whole thing to be true. So I'm going to change that back to a 6. Is 5 greater than 6? No, it's not. Is 10 greater than 9? Yes, it is. So since it's an OR statement, OR says since one of them's true, it's going to go into the if statement. Okay? So if I change this to a 3, I change that to a 12, or 13 in this case. So is 5 greater than 3? Yes, that's true. Is 10 greater than 13? No, it's not. But since one of them's true, it's going to go into the if statement. Now, is 5 greater than 7? No, that's false. Is 10 greater than 13? No, that's false. Since both sides are false, nothing's going to happen. That's what they're showing on the bottom of page 144 in the truth table for the OR operator. Okay. Now, on the top of page 145, we do have what is called a short circuit evaluation. And here's what that means. That means this. Let's change this back to an AND. So here we've got 5 and 7. And we've got 10 and 8. So C is greater than D. That is true. But let's take a look. It comes in, the first thing it does, it says, is 5 greater than 7? It's not. Well, guess what? Since it's an AND statement, right away it knows that this if statement's false right off the bat. It's not even going to check C greater than D. So that's called the short circuit evaluation. It doesn't even bother to check C greater than D because A is not greater than B. There's no need to check anything else. So it's going to basically come out. And same thing here. If this was an OR statement, so I've got OR, and I've got 3 and 13. Well, right off the bat, 5 is greater than 3. Since it's true, there's no need to check anything else because guess what? That's already true, so it's going to basically go into the if statement. So the short circuit here is it's not even going to check C greater than D because A is greater than B, and it's basically going to go into that. Now, not logic is, I don't like not logic, but And here's why I don't like it. I can come in here and say, if not A greater than B. And you'll see this sometimes. What that really means is this. If A is less than or equal to B. These two if statements are identical. They do the same exact check. Which one's easier to read? Well, obviously this one is. If A less than or equal to B. If A is not greater than B, it doesn't kind of come into your brain and flow real easy. This flows real easy, very easy to understand. That not so well. So try to avoid not logic. Sometimes you can't, but if you can, try to avoid it. Because if it's not true, it's false. If it's not false, it's true. Okay? So that's basically what we're doing there. So let's take a look at that loan qualifier again. We're going to look at loan qualifier 2. So this time we got our min salary and our min years of 30,000 and 2. We get the same input from our user, convert it to a float, and then we're going to ask for the same years on the job, convert it to an int. This time we got one if statement. We got if salary is greater than or equal to min salary and years on the job are greater than or equal to min years, we're going to print you qualify for the loan, else you don't qualify for the loan. So again, if we run this, I'm going to type in 50 and 1. That says we don't qualify for the loan. And I run it again, I'm going to type in 25 and 5. You don't qualify for the loan. Now, this gives the same type of input as we saw before. Now, the big difference here is this. We don't know why we didn't qualify for the loan. In the other one, it told us you didn't have enough years in the job. You didn't have enough annual salary. This time, it just tells us, sorry, you don't qualify for the loan. Now, what it comes down to is what's important. What do we need to tell the user? Okay. Instead of having this basically nested if statement inside another if statement, we just have an if else. And it's very, very simple and it does the job. The only difference is how much information do we need to give the user, and that's where that comes into play there as well. Let's do this. Let's open up loan qualifier 3. But this time we've got an or statement. Okay, so it's the same exact, it's just like the loan qualifier 2, except right here this has got an and this one has an or. Okay, now remember about the or, only one of them has to be true for the whole thing to be considered true. So we run it, and I'm going to type in 50, 1, 2, 3, and 1. Boom, and you qualify for the loan. Why? Because I had enough annual salary. I run it again. This time I'm going to type in the 25, 1, 2, 3, and 5, and I qualify for the loan because now I had enough years on the job. So that's the nice thing about the or statement is only one of them has to be true. So again, it really all depends on what you need for your program. Does your program need an and statement? Do you need an or? I work for an insurance company, and we might have things like if this person is a male, if their age is between 16 and 25, and they've had one ticket, they're going to pay a larger premium for insurance than with those things, if all three of those things are true. Now, if maybe they're between the ages of 16 and 25, and they're a male, 16, 25, and they're not high risk, then they basically might fall into something else. So again, we've got these and statements there that can determine if this is true and this is true and this is true, this is going to happen. So we have seen integers and floats. Now let's talk about Boolean variables. Now, a Boolean variable is just what we talked about a second ago. It basically is either true or false. Okay? And what's nice about this is, let's say I have a situation like this, where I'm going to say, let me put that back. I'm going to say if I'm going to create a qualifies is equal to false. Okay? And instead of saying print here, I'm going to X that down here. Same way with this guy. You know what? I'm going to try something else. I'm going to copy this guy and put it down here. Bear with me. Instead of saying print here, I'm going to say qualifies equals true. Else qualifies equals false. Now, so now I've got a Boolean variable called qualifies. I'm going to set it to false. I'm going to say if the salary is greater than or equal to min salary, or years in the job is greater than or equal to min years, qualifies equals true. Else qualifies equals false. And I'm going to come down here. I'm going to say if qualifies equals true, you qualify for the loan. Else you don't qualify for the loan. Now, what's nice about this Boolean expression is I don't even need the equals true. I can actually get rid of that. And it says if qualifies, and that basically makes the assumption of true. So if I have a Boolean variable and I say if that Boolean variable, I'm actually saying is that true. So that's why in these particular cases we like to give that Boolean variable a nice distinctive name, like in this case, qualifies. Because now that reads just how it sounds. If qualifies, you qualify for the loan. Else you don't qualify for the loan. So again, if I run this and I type in 50,000, I've only been there 1 year, I get an error. Line 13. Well, let's comment that out and see what happens. Doesn't like that either. Hold on. This is where my Java knowledge gets me in trouble. This is kind of a good thing to let you guys know what's going on. With Python, the Boolean expression true and false are capital F and capital T. So I'm almost kind of glad that happened, because really that's a good lesson to be learned as far as Booleans. The true and the false must be uppercase. Now let's see if it works. So here's 50, 1, 2, 3, and 1 year, you qualify for the loan, and 25, 1, 2, 3, and 5 years, you qualify for the loan. So again, if you're using Boolean, trues and false, make sure the F or the T is uppercase. Okay. Okay, go ahead and take some time to go ahead and do on page 162 the age classifier before we actually get, I'm not going to go right into the turtle. I'm just going to give you some pointers. But if you could do that, go in and do that age classifier and then come back and resume this video. Okay, so what we have done, I think I have it in here. Did I not have it? I thought I had the turtle. Give me a sec. Yeah, it's called Hit the Target. It's the turtle. So what you have to do is this. I'm going to highlight that whole thing and do a copy. And I'm going to go back and open up the turtle editor. And this is where you're going to have to, it's going to take a little bit of work. I'm going to do this. I'm going to throw it into Notepad. And what I'm going to do is I'm going to do an edit, replace, turtle dot to T dot, and replace all. And then I'm going to, after input turtle, I'm going to say T equals turtle dot, capital T turtle, left and right braces. And I think we need to, we could change this as well. I'm going to change this to like 50 and 150. Let's see how that works. There's something else that's going to blow up on us too, and I think is this setup screen. I've got to comment that out as well, so let's comment that out. Now I'm going to do a Control A, Control C, and I'm going to throw it over here in Turtle. And let's see if it works. Line 44. It doesn't like line 44. Can we just do input? Let's just try input here. Let's try that. It doesn't like input either. Huh. I could have sworn I had this work the other day. Let's get rid of this input right here. Oh. Get out of there. Get rid of that input as well. And let's see if that. Well, the box is showing up. That's what I wanted to happen there. We need to get the input somehow. Let me work on this. For some reason, they won't. This turtle program won't let us use the input. So what I did is I just hard coded some numbers in here. So this is what you have to do to kind of play around with it. I'm going to put in 45 and a force of, I'll leave it as 6. And then I run it. And we're trying to get this arrow inside that box. Not quite there. Let's do 50. Oh, we're closer. Okay. Anyways, you kind of got an idea of what to do there. So go ahead and play around with this. See if you can get that finally to get into the box. I notice every time I don't get in there, it says you missed the target down here. And so, yeah, so play around with that, have some fun. When you get done, go ahead and do the homework, and we'll see you next week.